Did you know that your postal address wasn't always at the same location on the Earth? Hundreds of millions of years ago, our planet looked completely different from how it does today. There were times when there was only one supercontinent, which then separated into smaller chunks of land. These land masses were drifting and colliding over the Earth's surface, and over time this had a major influence on the Earth's climate and the development of life on the Earth. Say, for example, Antarctica, one of the coldest and driest places on our planet today, was once covered in lush tropical forests. We know this thanks to the careful scientific observation of rocks and fossils found in them, and the science that does this kind of study is called paleontology. You've heard of dinosaur fossils, right? But dinosaurs are not the only organisms that can become fossils. Any organism under the right condition can become a fossil, and studying about them can teach us a lot about the deep past. But finding a fossil is not an easy task. For example, in a country where I come from, Serbia, finding a fossil is not impossible, but it is very rare. While in a country of a comparable size such as Lithuania, we can find a lot of them just by walking on the beach. Luckily for scientists, there are places that are abundant in the number of fossils that we can dig up. And even better, there are fossil jackpots, sites of exceptionally well-preserved fossils called conservation Lagerstätten. At these sites, preservation extends beyond just the preservation of bones and shells to the preservation of soft tissue that would normally rot away. This happens when an organism dies in environments that are unusually low in oxygen, highly saline, very cold, or extremely dry. These sites are like windows into the past and can give us a more complete view of life in ancient ecosystems and can help fill the gaps in knowledge that we have connecting extinct organisms with the ones that are inhabiting our planet today. But these sites are very rare. There are only around 40 of them from the last 500 million years. One of the most famous one is Solnhofen Plattenkalk, located in the south of Germany, in Bavaria, and it's 150 million years old, from the late Jurassic period, the time when dinosaurs roamed our planet. I'm standing now at the Solnhofen Plattenkalk Conservation Lagerstätten. Can you imagine that back then Europe was just like Antarctica, a tropical paradise, and most of it was covered by the sea? At that time, area known today as Bavaria in south of Germany was dotted by the coral and sponge reefs and shallow lagoons of the Solnhofen archipelago, and the open sea lay to the west and to the south. This is one of the Solnhofen limestone quarries, and if I would go back in time, I would be standing at the bottom of the shallow sea, which was once part of the primordial Mediterranean, so-called Tethys Ocean, which separated the only two land masses on our planet at that time. But dinosaurs were not the only animals that lived on the Earth at that time. Vicious marine reptiles dominated the waters of the Tethys Oceans, while various fish were swimming around. On land, early mammals scampered in the trees and first birds took to the sky. This site is actually world famous for the discovery of the earliest bird species named Archaeopteryx. We know all of this because paleontologists have recovered thousands of exceptionally well-preserved fossils of fish, starfish, shellfish, insects, and other organisms that normally don't fossilize. I'm very excited about these discoveries because they provide us an insight into the rich marine life of this particular period. Look at the preservation of this little fish. It is absolutely exquisite. The skeleton is fully articulated and the details of the bones are clearly visible. Other fish specimens were found with the preservation of soft tissue, scales, stomach contents of their last prey, and even color. Researchers think that high-quality preservation is related to the extremely low levels of oxygen in parts of Jurassic oceans. Free of most scavengers, these low oxygen areas in the shallow lagoons could have been an ideal place for a carcass to lay undisturbed, covered by the fine layers of mud, and become beautifully fossilized. Scientists have been studying these fossils for a long time and discovered amazing things about long-gone animals and plants. For example, they have been studying in detail fossil fish, their inner structure, form and shape. As a master student of paleontology, I got an amazing chance to study these fossil fish. I'm learning new methods to examine the food chain of different fish species that are coming from Solnhofen archipelago. The fish fossils were made available to study by the Juramuseum from Eichstätt. I collected tiny fragments from their scales, and I will use these powerful machines to perform chemical analysis. The most commonly used tool for studying the diet of extinct organisms is measuring the concentrations of elements such as strontium, calcium, and barium. If we applied these measurements on humans, you and I, as top consumers, would have the lowest values, while the fish we have eaten would have higher values. When it comes to extinct fish, this can give us a clue about their mode of life and their behavior, who ate whom, and as a result, we can place each species exactly to where it belongs in the food chain. As you can see, Earth's history doesn't just begin or end with humans. It is much more than that. Our planet is 4.6 billion years old, and during that time it has constantly been changing along with the organisms that inhabit it. And it is the dream of the scientist to unlock the secrets that rocks and fossils saved for us as the witnesses of the deep past. So, paleontology is not only about looking for fossils or collecting rocks. We, paleontologists, are like time-traveling detectives. We use different methods to study long-gone organisms and the ecosystems they lived in, and this is very important for predicting the future of our planet.